Good morning, everyone. It's amazing to be here. It's really humbling and we're privileged to be here. We've come all the way from Australia today. We've got an all Aussie cast here and we're super excited to be here. And before we start this session, I just wanted to say a huge thank you for being here. It is absolutely humbling for us to see you guys here, so we really appreciate your time. I know it's a very busy conference and it's the last day, and we really appreciate your time here today. What we have today is a really amazing customer story. A customer who was first succumbed to a DDoS event, and this story goes along how they moved from there and utilized AWS WAF Bot Control to extend their security posture in the layer 7 segment. Clicker. Fantastic. Yeah, in terms of introductions, my name is Robbie Correa. I'm a senior solutions architect at AWS, specializing in the retail industry. And alongside me, I have the greatest privilege of having my customer, Cameron Hall. He's a platform engineering lead at Catch, and also my very talented colleague, Etienne Munich. He's the senior edge solutions architect at Amazon Web Services. All right, so let me set the agenda. In terms of my talk, I'm going to be setting up the global threat landscape in terms of what kind of bad actors that's available and what kind of attack vectors that we're going to be talking about. I'm going to show you some data and some statistics to understand where some of these bad actors are investing their time and energy into, so we can protect ourselves against those. Then I'm going to be handing it over to Cameron, who's going to be talking about their journey of how they went from a DDoS event and how they secured their workloads after that event utilizing AWS WAF Bot Control. And then finally, Etienne will come in and talk to us about some of the tips and tricks and guidance that you can employ to get started as quickly as today. All right, so I'm going to set the scene in terms of the last 12 months in terms of statistics. These statistics have been shared by our AWS Shield response team, who is responsible for protecting us against some of these DDoS events. Over the last 12 months, we have had a total of 212,000 DDoS events. Now, if you look at the detail around some of these events, you can see that there's been 155 million requests when it comes to the largest request flood event. If you think about volumetric attacks, it came in at a whopping 842 gigabits per second. And the largest packet attack or the protocol attack came in at 221 million requests per second. So I want you to focus on some of these numbers. The reason why I'm showing you these numbers is for you to understand the scale and gravity of some of these attacks that is coming through our front door, so that you are inspired by these numbers to take some action as quickly as possible. All right, so I guess historically, if you think about DDoS, and when somebody says DDoS, we initially think about some of the attack vectors when it comes to infrastructure and networking type of attacks. So that's where the volumetric attacks and your protocol attacks come into play. However, our bad actors are getting much more sophisticated day after day after day, and they're moving up the OSI model from layer 3 to layer 4, right up to layer 7. So if you think about application layer or layer 7 or HTTP attacks, as you can see on this slide, it is exponentially increasing year after year. In 2019, the largest request flood came in at 1.5 million requests per second, and it's bubbled to 100 times in only 5 years to 155 million requests per second. If you look at the number of the application layer DDoS events that's occurring, you can see over the last year alone, we have gone from 100,000 events in Q1 to 164,000 events in Q4. If you look at the sum of it, that's a 52.1% year-on-year increase. So hopefully these statistics provide you some level of guidance around where our bad actors are now putting in more and more time against, so that we can align ourselves, because everything is limited. So we want to make sure that we put in the right amount of time in the right areas to protect some of our workloads. And this is why we're here to talk about bot control. Bot control is an application layer, a mitigation and setup. All right, so performance matters to our customers because, as Jeff Bezos says in his very famous 1997 letter to the shareholders, our customers are wonderfully and beautifully dissatisfied. And that's a good thing for us. As organizations, we want to make sure that we put our best foot forward. So how do we do that? We want to be putting our workload in the most optimum and more performance state. So I'm from a retail industry, so I'm going to be showing you some retail statistics, but I just wanted to emphasize that this is not a retail-specific challenge. If you have customers in your particular industry, as customers are wonderfully and beautifully dissatisfied, you want to make sure that you put your best foot forward for your customers. So looking at some retail statistics, you can see that 70% of our customers are influenced by page speed. Customers have multiple choices. If I wanted to get a pair of jeans, I have plenty of options. There's alternative products, there's vendors, there's marketplaces. 17% decreased conversion. What is conversion? Conversion is a retail term which loosely translates to the likelihood of your customers transacting with you online. So what this says is that, let's say, for example, you have 1 million customers in your e-commerce website. There is a likelihood of 17% of that, which is 170,000 customers, falling off if you increase your latency by an additional 1 second. And 15% of our customers are already frustrated with the slow checkout process. Imagine if you introduce a little bit more latency into that process. So performance matters to our customers. Now we understand that. Well, we understand that anyway. So why are we aligning performance with bot control? Because bots have this innate nature of slowing down and adding additional latency into your workloads by coming in and providing attacks from a distributed nature and increasing the workload or the traffic to your workloads. So, and worst case scenario, they can also have it in a state that your website is completely unavailable. If you think about the overall traffic, internet traffic, over 47% of that is bot-based. So humans like you and me, with all of the online transactions that we're doing, all of the e-commerce activity, everything only accounts for 53%. Everything else is bots. So not all bots are bad. There are good bots and bad bots. If you think about an example of a good bot, search engine bots come to mind, where they will come in, index your websites, and have that available on your customer's favorite search engine. And that's a good opportunity for your organization. There's another new channel for your customers to come in through and transact on your website. But hey, we're not here to talk about only the good bots. We're at a security conference, so let's talk about some of the bad bots and some of the attack vectors. First one is content scraping. This is where bots will go in, scrape your content, and even potentially have it available on a malicious website. What will that provide? Your customers will have a subpar experience because now you've got additional traffic on your website. And also, it will affect your SEO ranking if your backlinks and your content is available on a malicious website. So that's one problem that we wanted to solve. The other one is credential stuffing. Bad actors can access leaked credentials on the dark web and utilize bots to brute force themselves through your login pages and try and gain access to your customers' accounts. Once you have customer account information and you can log into it, I'll let you imagine what kind of malicious activity you can do with that. Card cracking is another good example where bots can go through and try to brute force themselves through the payment providers. So your payment processor, once you get access to credit card information through that brute force attack, then you can utilize that for fraudulent transactions, which means customer trust is lost and you might have brand reputation loss. Account creation fraud is another good example where bots will go through and create thousands upon thousands of accounts. Why? They might want to utilize that to legitimize their identity, or they could gain financial benefits from things like new user sign up, or let's say referral bonuses, for instance. Scalping is another good example where bots will gain control of your inventory, have it available on let's say a temporary shopping basket. That means your customers won't be able to access that inventory, they can't transact online, customers dissatisfied, revenue loss. And finally, denial of service. This is a classic one where bots can introduce a distributed attack on your website, overwhelming your front end and potentially your back end fleets, and have it unavailable for your customers. Again, revenue loss, customer dissatisfaction. And this is what Catch had gone through. So I'm going to be introducing Cam to talk about their journey of how they went through this process and how they emerged victorious on the other side, utilizing AWS WAF Bot Control. Please give a round of applause to Cam, please.
Thanks for the introduction, Robbie. So Catch is a household brand in Australia. So I just want to tell you a little bit about Catch. So Catch is an online retailer. We've been online for over nearly 20 years. And it's a great place to shop for everyday low prices. It's a real entrepreneurial rags to riches story. So Catch started in 2006 with only 5 team members in a 200 square meter warehouse. And they offered a catch of the day, where they promoted one product per day at a really great price. At the time, it was a really unique value proposition, and people absolutely loved it. They flocked for the deal. And then the business began to grow from strength to strength. Now Catch isn't just an online retailer selling one thing a day. We're actually an online marketplace, and now we have 30,000 new customers every week, and we're shipping 20,000 products or different orders every single day. So that sort of brings Catch to be one of the largest e-commerce retail businesses in Australia. So now I've told you a little bit about Catch, let's talk about what you're all here for. So I want to wind back the clock to 2022. And this is where we were hit by our first DDoS attack. We had a pretty good run, and this is sort of what we woke up to. So it was 9 o'clock in the morning, I was on my way to work, and I was about to go to the new office, and I was about to head off to the new office, and my phone starts ringing. I haven't even sat down on the train. And you could sort of imagine what's going on. I'm not a morning person, and I look down at my phone, and it's just blowing up. Jump on Slack, same thing. We actually did a pretty good job. Within 2 minutes, we'd identified the attack. But it took us a little bit identified the incident, but it took us a little bit to actually work out what was going on. So this is what our customers would see. The lovely little guy saying that this isn't meant to happen, great. But what was happening? Behind the scenes, this is what was happening with our request traffic. So the team was looking at the stats, and we saw that the requests per second were much higher than normal. It's a little small, but there's a little yellow line at the bottom of the screen that's showing you what our typical request traffic looks like. So the traffic surge was 11 times more than our normal request traffic. Scaling isn't something that's unknown to us. We do it all the time. But to have a surge or a spike to 11 times in such a small period of time, it's not something you can really scale for that quickly. So our backend APIs, we're struggling to respond, and naturally, the experience just wasn't there. So let's sort of shift and pivot to what do we do after the attack, right? So we've been serving our site on CloudFront since 2011. So we've used CloudFront for a really long time, and that CDN capability has been fantastic. And because we're on CloudFront, we also have AWS Shield Standard. So we're a bit confused when we're hit by the attack. We thought, well, we've got AWS Shield. Why is our site being taken down? Aren't we protected from DOS attacks? And that is true, but in the fine print, what you'll notice is you're only protected from layer 3 and 4. So when we're starting to see the shift in the market, as Robbie showed before, or rather the industry, to the attacks have now moved from a layer 3, 4 to a 7, we just don't have that protection. And unfortunately, now we need to work out why. So after speaking with AWS, they quickly pointed us to, you need to have AWS Shield Advanced for that capability. So that's, yeah, we got there, and I'll talk a little bit more about that later. So I guess AWS Shield aside, we also had AWS WAF, and that's what we're really here to talk about. But we had left every single Amazon managed rule in count mode, and doing that doesn't really help anyone at all. So if you're wondering how that happens, well, what I failed to mention before is that working at Catch is very much like working at an enterprising startup. We're always trying to scramble to get things done. Some things aren't done to completion, and a lot of things are done all the way through. But this is one of those things where it's just sort of like there was a gap. So there's a natural fear when you're implementing WAF rules that you'll start blocking legitimate traffic. And this is even more true when it comes to aging, monolithic web applications like ours. Like I said before, we've been around since 2006, and this application has just evolved over time, so you can imagine the state that it's in. And I'd hazard a guess that this reason why, the fear of blocking legitimate traffic, is probably why our WAF was still in count. And in defense of the person that had set it up, I'm almost certain, and because I was the one that cut the ticket, that it had nothing more than a title that said, put AWS WAF in front of the website. And you know what, to their credit, they did exactly what it said on the tin. So in terms of incident response, the actions we took were to introduce a generous global rate limit. And we did that through analyzing the client traffic from just one of our browsers. So like we opened up Chrome, went to catch.com.au, and we said, great, okay, so it looks like that's our bar for requests. And then we took that and we put a generous buffer on top of that because we thought, surely some people are just going to click, 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 right? So we just wanted to have enough room to make sure we're catching most of what we'd expect. Like ultimately, we're just trying to protect our infrastructure from being smashed. So after we did that, we created a simple block list and a related playbook. So this is about what about next time, right? We know that someone's taken our site offline before. We're more thinking about what are we going to do the next time we need to respond to this kind of incident. And that playbook, it's an instruction manual for the next person that comes along, because it might not be myself or my team, so they can actually work out what they need to do and what actions to take to start blocking that traffic. And the last thing we did was we introduced a break glass geo-block rule. And this let us restrict traffic to just Australia and New Zealand, because that's our target market. So if you're in a position to do that, where you know that your target market is isolated to a particular geography, I can't recommend this kind of strategy more. This is a rule that you're leaving in count mode and switching to block in response to an attack. It's not going to protect you from everything, but it's just a tool to have in your tool belt for when you need to mitigate an attack. And it's proven more than useful on more than one occasion. So let's shift into the post-incident review. So by this time, the incident bridge had closed, and we're getting busy with our post-mortem. To our knowledge, we hadn't previously been the victim of a DOS attack, at least not one large enough to knock us offline or that we'd noticed. But regardless, we knew for a fact that if someone had knocked us offline before, they're going to do it again. It's a bit like a game. So ultimately, if our site's not online, we're unable to do business, and we're a marketplace, right? So if our site's not online, it's not just Catch that's not making money, it's our sellers that are relying on Catch to run their businesses. So it's really important that we have some assurance that we're able to always transact. So when we went to market, when we were attacked, it was sort of convenient timing, because that exact week, we were already in the process of preparing a request for proposal to go to market for a WAF, so a Web Application Protection Platform. So we were looking for something that had API security, CDN, DDoS protection, and bot control. Looking for an all-in-one solution. And there are a couple of big names in the market out there. And we met with all of them. And I'll tell you, after many tedious sales calls and demos and whatnot, we all started to realize that there's just one thing that they all had in common. Aside from the high level of service that comes with a lot of these other market providers, they all come with a really, really high price tag. And being a cost-conscious business, like Catch is that we're a low margin, high volume retailer. So being incredibly cost-conscious is something that's absolutely key to us when we're considering these types of investments. And we were started to gravitating towards these more white glove solutions, but we had to take a step back and reassess whether we could actually afford it, right? So yeah, that led us to look at reassess the AWS solution. I mean, we already had half of it in place. So we looked through the AWS solution and we're going, what are the features that it has? So what I missed sharing before was API security was a desire, but it wasn't absolutely key. Another thing that happened when we were assessing the market was we were looking for a GraphQL API security. And 2 years ago, when we were looking at this, every one of the vendors that we spoke with said the same thing. It's on the roadmap. So not having that capability there and not being prepared to pay for something that may be there eventually, we opted to just kick the can down the road. So when we did go to market, we were just looking at the CDN, the bot control, DDoS, and those three capabilities. So AWS, they offered us a 60-day Shield Advanced trial when we went to market to make sure we were protected. And then we came back to reassessing the AWS solution once we had the price shock. So looking at the AWS solution, it wasn't just about, excuse me. The AWS solution, it's a bit more do-it-yourself. Like it's a given, right? It's the building blocks. But what we found was that it's not just about the request cost when it comes to these things. It's also about the total cost of ownership. And what we had realized is that so what we had realized is that the starting price for any of these solutions that we're looking at was close to $250,000. And that's a really high number, and it's a fixed cost, right? It doesn't matter how much traffic you're going to be receiving or sending, like you got this minimum fixed cost. And I could have just signed the contract, closed it out, and made it a problem for the next guy that has to do the budget. But unfortunately, so when we looked at the AWS option, we assumed it's going to take, let's say, 3 months to set this up, get it mature and stable. And if we were to do that, 3 months for someone in tech, let's just assume that's going to cost $50K. So a $50K fixed cost for the first time setup, and then on top of the operating costs for the AWS solution, it generates a graph like the one that I'm showing on screen. So the total cost of ownership for us with the AWS option rendered savings of 2 times in the first year, and then 4 times every year thereafter. So that just made the AWS option only natural, right? We want to keep, at Catch, we try to keep things as native as possible. And it made sense, not just from a dollars and cents angle, but also because the implementation. So marketing aside, let's talk about the architecture and the tech behind it. So we're post-incident now, and we've got AWS Shield Advanced, AWS WAF, with the Amazon managed rules no longer in count, and bot control. Now, we also have this third-party bot protection solution that's still in place. and we had just gotten a renewal. And so you can imagine we're scrambling to be like, wow, do we really need this anymore? So the AWS solution for bot control at the time only protected you from common bots. So those that are Python scripts or headless browsers, the ones that you can detect through the signature-based methods. It couldn't protect you from those more sophisticated bots that were trying to emulate human behavior. And so as I said before, we were trying to get ourselves to a state where we had an all-in-one solution. And we wanted to simplify the way that we ingress traffic to our site. So it would look something a little like this. It really can't get much simpler. So how do we get there? At Black Friday of 2022, AWS introduced the targeted bot capability. And this was the one that was supposed to protect you from those that are trying to just hide what they're doing, look like a legitimate customer. We were a bit skeptical at first because it was AWS's first attempt at doing this. And the solution we've been using, we have been with them for well over 5 years. We knew that this isn't just, it's not a very simple thing to do, detecting bots. And it's something that takes time to get really good at. So we were a little reserved when AWS came out, but we were really eager to see what it could do. So our architecture was in such a way, like you can see here, that we were able to employ AWS's targeted bot protection, and have then anything that AWS missed would fall through to the third-party option. And then the third-party solution provided logs, which we then fed back to AWS so we could help them improve the bot product. This proved to be a really, really effective strategy, and that's part of the reason why I'm here talking to you today. So let me talk to you through about sort of how do we implement these rules, right? So there's a couple of hard lessons that we've learned through employing AWS WAF, and not just the bot control rules. This goes for everything. You can't just enable some of these rules, walk away, and hope for the best. Having gone to lunch more than one time after changing some rules and coming back to people flooding my inbox, I can tell you it's not the way to do it. So the first thing we do now, having introduced a process after going to lunch too many times, was implement every new rule in count mode. So starting with count, because what we want to do is we just want to see what's happening. AWS's WAF produces logs that are really, really detailed. So having this in count gives us an opportunity to observe what's going on. And then we can adjust and tailor with the rules by scoping them down as we see fit. There's guaranteed to be parts of your site, unless you're fortunate enough to have quite a modern application, where you're going to have some sort of bizarre behaviors that will get blocked naturally. So we just want to scope these down to make exceptions. And what we're trying to do here is build confidence that we're not actually blocking legit customer traffic, or perhaps good bots, like the SEO ranking bots and scrapers and whatnot. Once we build confidence, we'll promote the rules to block. But what we found was building confidence was a little challenging. And so that led us to, we needed to work out how do we understand what's going on? How do we understand the traffic patterns? Now, this was 2 years ago, and it was probably even true 6 months ago. But being able to see what's going on with these rules just natively out of the box with the AWS option, it's a challenge. So this led us to build a dashboard in Datadog. So we use Datadog for everything, so moving it here was just natural. We were using this to identify what are the rules that are being blocked most frequently. What are the rules being blocked most frequently? What's changed since yesterday? Do we have spikes in blocked requests, counts? Just trying to see what's happening, right? what we can do from here is we can dig in and we can start looking at, show me things that are being blocked specifically on these pages or these routes. And having this data available in Datadog was just a huge unlock from us. That slide I showed before with our workflow, that observe and adjust phase could take weeks for some rules, because the only thing you can do is evaluate this with live customer traffic. You can't run the rules against historical traffic to see what happens. So having that available through here, reduce that time frame from weeks to days. So I've glossed over a little bit about the difference between the common bots and the targeted bots. And I just want to cover it off briefly. So the common bot capability is for detecting those self-identifying and simple bots. Allow listing a known good, providing a list of known good bots. So out of the box, it's not going to start blocking Google scrapers or your health monitoring stuff. These are all backed by a database of known verified bots that AWS maintains internally. This is all done using signature-based methods. So if anyone's familiar with ModSec or something similar like that, just running regex rules against the expression, against the requests. And then it also uses additional data sources like IP reputation lists, DNS lookups, etc. Targeted bots, on the other hand, they're trying to identify the bots that are deliberately trying to be evasive. The only way to really identify these is through behavior-based methods. And so the ways that we're starting to identify these are using browser fingerprinting, interrogation, captures. We're all familiar with those, I hope. So the thing is, targeted bot protection, it's not as simple as flicking a switch. There's additional work that you have to do on your side to make sure that you can actually leverage the full capability of the suite. So that, with AWS WAF, that means we have to employ the WAF SDK. And that WAF SDK needs to be implemented not just your website, also on your mobile native apps if you have those as well. And I'll explain a little bit more about why in a moment. So looking at this, diving into the rule sets. So on the left-hand side, we've got our common rule sets. And as I said before, that's our signature-based methods. While it looks a bit overwhelming, you can leave most of this as is. However, I will call out one in particular because this one caught me out more than once. So the Signal non-browser user agent is documented incredibly well in AWS's documentation, particularly when you start looking at the mobile SDKs. But it's definitely worth a call out. If you have native apps, you need to override this rule to count mode and manage it separately further down your web ACL. The reason being is that it's a signature-based rule. AWS's rule sets aren't tailored for your application. They're generic. So you need to handle it separately and make sure that your apps aren't getting blocked. Now, on the right-hand side, we've got our targeted rule sets. Now, these targeted rule sets, they're the more behavior and ML-based detection methods. Now, this is why you need to employ the WAF SDK. So if we start thinking about how does AWS track and detect this traffic, IP addresses and headers aren't enough to correlate traffic. If we're starting to look at, we take Australia for example, CGNAT is a really common capability for ISPs to employ. So there's no guarantee that every customer or every household is going to have a unique IP. So what we want to do here is we want to start identifying unique clients. So employing the SDK generates, when a challenge rule is encountered in your web ACL, it will trigger a challenge token to be generated on your client side, which will uniquely identify the client. That'll be sent along with every following request. AWS's WAF will then correlate and aggregate all that data to then make decisions based upon the rules on screen. So today, we now use only AWS's Bot Control. We got all the way through to our desired end state that I showed before. And I'm hoping that I've enlightened you a little bit and shared some of the lessons that we learned. So just a quick recap. First thing to do when you're starting to play with AWS WAF, because we want the implementation to be synonymous. Use count actions when you're testing new rules, irrespective. Make sure you're addressing false positives using the scope down statements. These rule sets, as I've said before, are generic and they're not built for your application. But they are built for a reason. So make sure that you scope them down to make exceptions where you can. And finally, ensure that you're ingesting and analyzing the WAF logs. If you use CloudWatch, then that's fine. But make sure they're coming into your SIEM or some other observability platform, because aggregation is absolutely imperative. Now I'm going to hand over to Etienne, who will tell you how you can protect your website today.
Thank you, Cameron. If we can just give Cameron a... thank you. Really appreciate Cameron coming out and having a chat around some of these topics. It's important to know some of these sharp edges as you employ these protections and how you can implement these quite quickly. So that's what my part of the chat today is around. But before we start going down the rabbit hole, let's just talk about well-architected frameworks. This is always a journey for customers and by no means an expectation is a done deal. But it's important to take some important areas here that we want to focus on. When we look at volumetric attacks, this means that an application would need to be able to cope with a surge. Whilst you'll have controls at the edge of the network, the application still needs to scale up. So this is an important part of this puzzle. So I just wanted to call that out. Try build for scale. The second piece here is to employ CloudFront and Route 53. Route 53 is one of our services that have quite a high SLA, and so this is something you would want to leverage for DDoS attacks against DNS services. You want your service to be available and to be able to be resolved. So just by using Route 53, you get a lot of availability for your DNS services. The next piece is CloudFront, and CloudFront offers you caching capabilities. I always say, use the acronym ABC, always be caching. The more you cache, the more you offload off your origin services. So wherever possible, cache. This means you may need to do a bit of an investigation around your logs to see where there's opportunity to do this. Easy wins are your static assets, but there are opportunities to cache other objects that may need to be cached for short periods of time for dynamic origins. The next piece in this puzzle is part of protecting your origin is to restrict access to that origin. So in this case, in this diagram, we've got an ALB, and an ALB can be protected with VPC prefix lists and secret headers. VPC prefix lists mean that you can restrict access to IP addresses from CloudFront POPs. It's a simple IP protection. The next is a secret header to ensure that only your CloudFront distribution communicates with your origin. And you can run a rule on the ALB to deny any request that does not have that secret header. So the intent here is to have a secure path through this chain. Now, your architecture may look a bit different on the origin side, but those are just some of the talking points for how you would protect your origin. In the case of using Shield Advanced, this is where you would want to nominate your Route 53 zone and your CloudFront distribution. Where Shield Advanced fits in this picture is that it helps you deal with mitigations of volumetric attacks and will update WAF on your behalf with automatic rule group, updating automatic mitigations. Shield Advanced will actually update your WAF web ACL on your behalf when there's a volumetric attack. All right, so we've spoken a little bit about building these applications to be available and where you would want to employ these protections at the edge. But let's talk a little bit about how you would build these WAF rules. These WAF rules, you can divide it into a mental model of certain areas, and I'm going to just describe some of these areas and show you how you can employ these protections. The first area that you would want to have quick wins in are block lists that you know that you've got risk for. Often when you're employing bot control or these other services, you would want to have an understanding of your risk. but you may already have an understanding of some of the risk that you're facing, and so block lists are a great way to do this. Your block list may include IP addresses, you may have header matches, cookie matches, session matches. There may be a number of different criteria that you would want to build into there. The next piece in the puzzle would be to leverage Amazon managed rule sets for IP reputation. These IP reputation rules filter up things such as Tor nodes and that of anonymizing proxies, VPN services, known DDoS networks and bot networks. So these risks can be quickly mitigated in your higher order of your rule set. If you've elected to subscribe to Shield Advanced, you could place that rule group there. This is where Shield Advanced will update this rule set for you. The next step would then to employ protections for your workload. It's what we would call baseline or use case specific rules. And so if you have a Windows environment, Linux environment, if you have any form submission, you would want to perhaps protect with SQL injection type protections. And you would place these rules here. So in this rule order, you would place those protections there. The next is availability protection. This is control where you would want to use multiple rate-based rules. You can place as many rate-based rules as you want here, right? So you could set up 5 or more rate-based rules to employ protections for geolocation, for that of HTTP method, and such. You can use labels from higher up in the order list, from the IP reputation list, to limit access or issue capture challenges and actions based on this. So rate-based rules are a very powerful way to employ these types of controls. Oops. All right. Lastly is to employ our intelligent threat mitigation rule sets. This is bot control, common, for common bots and for targeted bots, and to consider our account takeover fraud prevention rule set and account creation fraud prevention rule sets. I'll talk a little bit more about those rule sets and how those labels work shortly in terms of labels. But this is where these rules would be scoped in the order of evaluation. Because as you evaluate a request, that's a top-down approach. So the rule order priority matters here. So metadata is added to request as it passes through this. So when we look at this here, those labels are added as it goes through that evaluation. Let me give you an example here of what bot control does. Bot control issues these labels for a category of bot, but it will also give you the specific bot you're dealing with there. In the first line there, you can see that we've got a category of search engine when we've got a detection for that. And so if it was DuckDuckBot that was accessing your service or indexing your service, that would be added to your logs as well. But those same labels can be used to drive an outcome. For example, you may want to decide that you don't want any search engine to access, but that of DuckDuckBot. And you can choose to do so using scope down statements. Block all bots and then allow a specific category. So these labels give you fine-grained controls. All right. So we've got this functionality, but what can you do today if you had to walk out of here today and start? In the CloudFront console and the ALB console, we now have one-click deploy of WAF. This gives you some key controls, and I would recommend if you don't have anything there, consider this as a good starting point. The one-click deploy gives you SQLi or SQL injection protections. It will give you rate-based rules in count mode so that you can determine what your rates are to set a limit, and it will give you IP reputation protections. And so these are what I would call kind of a baseline to employ protections for your service. Once you have that, you would then start to use the WAF dashboard and start to see what's happening on your service. Then add bot control for targeted bots in count mode. The reason we start in count mode is because you want to see what signal you're getting. And if you're protecting authentication pages, add the account takeover prevention rule set as well. Those same labels are issued for all that metadata for both of these services. The WAF dashboard will give you visibility of the risk, and you can then start to choose the action that you want. WAF has 5 actions that you can use: count, block, allow. It has challenge, which is like a silent capture, give the browser some work to do, and capture itself. We offer capture in 2 different flavors, that of server-side capture and that of a JavaScript component that you can employ. But you can choose these actions on the server side and implement these protections quite quickly. Lastly, use scope down statements. Scope down statements offer you the capability to filter out and mitigate false positives. It'll help you put protections in for the URIs that you want to protect for, so that you limit your bot control cost without having to have runaway costs. And so this is an important part of making sure that you can mitigate for bots, but keep it on budget. All right. Again, yeah, thank you very much for coming to visit us today. I hope this has given you some insight into how to use bot control and these rule sets and how to place these rules in order to provide protections for your service. I did want to have one call out. If there's one thing that you bookmarked today, this is it. This is a prescriptive guidance documentation that gives the same mental model that we've discussed today in this document and how you can implement it today. So I recommend bookmarking this one. Whilst you have your phone out, please, if you could complete a survey for us. We really take the survey data back so that we can help improve what we do. So we would value your feedback there as well. All right. Yeah, thank you, everyone. Yeah, thank you. Lastly, the team and myself will be at the Secure CDN booth after this. So if you have any questions, if you want to chat through anything, please feel free to catch up with us there. Thank you.